right. Well, thanks for your flexibility, everyone, and thanks to Cam for getting our lovely snacks. Can you believe this was provided by the university? So anyway, Dan's going to take us home and kind of give us a summary. And so I'm sure you all know Dan. And so, he's another one of us ISU folks who've slowly infiltrated this part of the world over the years and went to Australia. And, the whole time he was working on very old, very crystalline rocks, quartzites, and even some metamorphic rocks. And like all mappers that come here, he got sucked into the gravels, although I think he did it in record time. It took most of the mappers here decades to get sucked into the gravels. And so Dan got sucked in right away. And so he's going to present some of this work from his mapping in the Dillon area that is now wrapped up. So he's kind of putting a bow on all this. So with that, I'll let him take it away.
Awesome. Thanks, Stuart. Yeah, so today I'm going to be talking about the pulse of Yellowstone in the Ruby Graben of southwestern Montana. So having given poorly attended talks before, I tried to get a catchy title. So before we kind of dig into the main topic of the talk, I guess I'll put a little plug for the Tobacco Root Geological Society Conference that's coming up in July. I think a lot of you probably know about this and are planning on attending, but really we'll be highlighting the Dillon 100K map that Jesse's been leading and working on for probably the last 10 years and a bunch of field trips around. And throughout this talk, and wisdom as well, yes. And so part of this talk is structured a little bit about a field trip I'm going to be giving on the last day of the conference. So without further ado, I want to thank everyone that helped make this kind of, I would say, a dream team lineup for the tertiary seminar this year. So I think it was actually Cam was the original kind of firecracker that got us going. And then, Stuart, myself, Colleen, we've had a lot of fun with this. So I'm, a lot of things I'm going to be talking about and touching on today build off kind of all the talks we had earlier this year. And so I thought I'd do a quick rundown. So starts off, we had Bob Schwartz, who talked about the Paleogene Basin Network. And the thing that really stuck with me was kind of the facies-based approach he took to looking at these rocks. We had Rob Thomas following him up, talking about the 6 Mile Creek Formation, the three members, and these young northwest trending mountain ranges, and kind of his lithostratigraphic approach to the 6 Mile Creek Formation. We had Debbie Hanneman, and what I took away from Debbie's was really the importance of unconformities within this tertiary and correlating those unconformities. Then we had the following talks. We had Don talking about world-class vertebrate and mammal fossilist images. Carlos sharing some of his PhD work on 6 Mile Creek. We had Deke, which I actually missed this talk, but I watched a YouTube video talking about one of those significant unconformities at around 20 MA that Debbie touched on. We had Lydia talking about large detrital zircon data sets and modeling and kind of paleo-continental divide drainages. So I'd say, she really focused on the migration of these paleo divides. And then we finished up with Whitney, who talked about sand, gravel, and aggregates and how important they are to kind of the industry and economy of Montana. So I highlighted kind of 4 of these talks, Bob, Rob, Debbie, and Lydia, and kind of the main, one-word summaries: facies, lithostratigraphy, unconformities, and paleo divides, because I think my following talk is going to basically build off a lot of their ideas. And I feel like, those talks are really fundamental for how I kind of thought about the stuff that I mapped with the state map team. So unfortunately, I would say we can't say the same about our MBMG basketball season this semester. We took proud to take last place. We did somehow, there was a lot of hustle on defense, so we didn't get the most points scored on, but the second most. But yeah, so that was quite fun. And I really want to highlight, I'm the one up here talking, but this was really a team effort between particularly Jesse leading the Dillon 100K, chats out with Colleen, Stuart, Jan, Trish, everyone. So this is definitely kind of a product of the whole state map team. And so just to get us situated where we are in Montana and in the world for this talk. So I think almost every talk we had this semester probably showed some configuration of this Yellowstone hotspot track across Idaho into northwestern Montana to the current Yellowstone hotspot location. And this talk is going to be focusing on basically the Dillon region, and outlined in here is a Dillon 30 by 60 degree quad. And in orange, you can see the extent of tertiary rocks. So if we zoom in to kind of the simplified map from the state map of the Dillon area, we're going to be focusing kind of in the south eastern portion in the upper Ruby Valley. And this is actually a figure from my TRGS field trip I'm going to give. And we're going to be visiting a couple of these locations within the valley and talking about some observations there. But one takeaway I want to take on this, away from this, you see the most common color on this map is mostly what? Oranges and yellows, right? So, you know, I didn't calculate the exact area, but roughly half of the map area is tertiary sediments or quaternary sediments overlying tertiary. So definitely, you know, covers a big area and a lot of people live there. And so trying to understand them, I think, is a worthy cause. So everything on the map that was orange, that was TS. What is TS? You might remember this from some previous talks. Well, it's tertiary sediments. And in most of southwestern Montana, it's broken up into two different units that combined make up the Bozeman group. So we have the lower formation is the Renova formation. And then the upper formation is the 6-Mile Creek Formation. And so this is kind of taken from a combination of, you know, Susan Book and Rob Thomas and Jim Sears figures. And I added on here all those important sequence boundaries that Debbie talked about in her talk. And unfortunately, I have to apologize to the Renova Formation fans in the group. We're going to be focusing mostly on the younger 6-Mile Creek Formation rocks. And so Stuart kind of stole these slides so I can punch through them. But yeah, I mean, prior to arriving at the Bureau a little less than 3 years ago, I pretty much ignored that entire part of the geologic timescale that's covered. And then on my first day here, I basically, you know, was thrown into an area that was, you know, 80% or 75% rocks at this age. So I definitely had to, you know, learn quick and adapt. And I am a huge fan of the Centennial volume we did. I actually think it would be awesome. Like every new employee should get one of these because it's such a great resource. So I think, I don't know if it was the first paper I read, but at the Bureau, but if not, it was one of the first. This paper by Rob Thomas and Jim Sears. And I wanted to highlight some, basically 2 paragraphs they had in their conclusion because, you know, I'm definitely under the conclusion. One of the hardest things about being a scientist is identifying what the gap in the knowledge is, what's going to be your contribution. You know, you read stuff and it seems like almost everything's been done. So I love that they kind of laid this out. And I'll just highlight, this is kind of a lot of what Rob talked about, the 3 distinct interleaved members of the 6-Mile Creek Formation. And they kind of had a call to action, which I love to see. They said extensive additional detailed work in the 6-Mile Creek is needed to help establish regional stratigraphic relationships, depositional and tectonic history, and determine if it should be all be mapped as 6-Mile Creek throughout its current extent. So I thought to myself, oh, I could be that person. And they talked a little bit about the complexities of the terrestrial depositional systems. So that's gonna be something I'm gonna touch on a lot, kind of further in the talk. In my opinion or approach is that, you know, I think really the only way to understand the 6-Mile Creek Formation is to think of it in terms of depositional systems. And then I added this here in red. They said people have tried to map the 6-Mile Creek in the past, and it's resulted in poor results and confusion for students and new MBMG mappers like myself. So that was kind of the background that I had when I first headed into the field. So basically, almost all the observations that I'm going to be directly talking about relate to this area of the world, which are the 4.5 quads that I've kind of visited in my first 3 field seasons here. So, you know, this one's published, that one should be out soon. And then I worked on these the last 2 years with Jan and Jesse and Colleen to kind of compile that into the Dillon 100K. So kind of based on my understanding of the 6-Mile Creek and some of these talks, I wanted to highlight what I thought were 3 kind of gaps in the knowledge or places where we could learn more about this formation. And because sometimes I tend to be a little long-winded in talks, I actually color-coded these. So they're green, yellow, and red. And this bar down here at the end will change colors if you're starting to be like, oh, are we almost near the end? So the first gap in the knowledge, I think, is, and I think Rob and Jim talked about this in their paper, is what's the best way to map or subdivide the 6 Mile Creek Formation? And I kind of define best as what approach would maximize our understanding of the Neogene basins. Second question, kind of building off Debbie's work, is what is the timing and possible tectonic mechanisms for the unconformities that bound the 6 Mile Creek Formation? And then finally, this kind of touches a little bit on the big picture stuff that Lydia talked about. What can the provenance of the 6 Mile Creek Formation in the Dillon area and in the Ruby Graben where I worked tell us about large continental scale drainage systems and drainage divides? So to start at the very beginning, my first impression after kind of reading some of the literature and the subdivision of the 6 Mile Creek Formation was the lithological characteristics of these three members. The Sweetwater Creek member down here is described as kind of coarse, angular sediments, some debris flows. The term fanglomerate is used a lot. So proximally sourced, angular, immature sediment shed off uplifted regions in the basin is what characterized the Sweetwater Creek member. The next member, the Anderson Ranch member, was really characterized by these reworked tufaceous beds. So reworked tuffs, tufaceous sandstones, things like that. And a lot of them are reworked in fluvial systems. So they've discussed how they're, interbedded with a lot of, fluvial channels and things like that. But really, I think, from my understanding, was one of the most characteristic aspects of the Anderson Ranch member was these tufaceous beds. And then the Big Hole River member is large, rounded, presumably distally sourced quartzite cobbles. A lot of quartzite cobbles like this can be found in the upper Ruby Graben. And Jim. Sorry. Am I good now? All right. Sorry to everyone listening that you missed that first 10 slides. Or okay. Didn't that? No, it was muted. Okay. We'll just keep going. Yeah, and so the first place I actually looked at these in the field was with Jesse on his mapper of Red Canyon. And we were looking in the kind of iconic Timber Hill locality. So this was a pretty cool kind of outreach Yellowstone Volcano Observatory article that Jesse wrote. And I was looking at this plateau offset by these young northwest trending normal faults that Rob Thomas mentioned, but this, topographic high plateau or mesa, I guess, of Timber Hill basalt. That's a 6 million year old basalt flow within the 6 Mile Creek Formation.
If the chat is almost looks like some of this.
Oh, Chance said I could hear you the whole time. Oh, okay, great. Okay. That's good. I'll keep going then. And so yeah, so now I'll just get to it and describe some of the outcrops and lithologies I saw in the field. So I mean, it's really interesting rocks to look at. There's some really cool features. Like right here, you can see a fluvial gravel channel that's offset by a fault beneath a continuous horizon. A lot of this kind of immature tufaceous sandstone. You can see some of these large white colored tuffra beds, evidence of active faulting in the basement. You can see kind of a little Horst and Graben structure there. This is an injectite, so probably saturated sediment. Basically, the overpressure caused it to inject up within these layers. Here we see, I think these are some small anti-dunes. So those form during fast flowing upper flow regime water. And so basically a lot of these, first photos kind of show, there is no shortage of sediment within kind of this depositional system that's shown by these photos. But it wasn't all fluvial. Here's some really large scale foresets, some Aeolian dune foresets. Here's some, I believe this resistant kind of layer on top is one of those paleosols, a calcic paleosol that Debbie mentioned in a few of her talks. I see some reverse grading in some of these fine scale tophaceous beds, suggesting some Aeolian transport the wind was blowing around this volcanic ash and glass. And we see just a ton of these large round cobble channels. They're everywhere. I should have had even more pictures of them because, I mean, a lot of the mapping is just walking over round cobble strewn across the hillside. I put this in for Don. I didn't find a ton of fossils, but I actually found this the one day I spent out there with Stuart. It was quite cool. This is a fairly large, you can see for scale, the notebook, fairly large fossil that we found that probably something if you're out on the landscape all the time, this animal, died, its body decayed, and the fossil, its bone was washed down and, into a fluvial channel. And we also see these huge, thick packages of conglomerate. And these look different than kind of the more well-sorted, rounded conglomerate channels that we show earlier. A lot of this is quite angular. Oftentimes, I'll touch on it even later, you can correlate even, the identity of some of these angular cobbles to the adjacent uplifted bedrock. And really one of the things I want to highlight is the beds change a lot along strike as you follow them out through the basin. So along the same time horizon, you can see changes in lithology. And that's kind of what I'm trying to show here. So, near the range front or the presumable margin of the basin when this unit was deposited, you see these huge cores, and with this hammer's 16 inches, some of these boulders are close to 1 meter in size. And you can follow some of these beds out towards the axis, towards the center of the basin, and you can trace out these same basically angular class. And they find as they get further and further away from the range front until eventually they get to be quite fine grained sandstones and intermixed with some, maybe even tophaceous material. But then if you keep following out, you then go back from fine grained stuff back into coarse grained stuff. But it has a different nature, the more well-rounded, better sorted fluvial channels. And so I agree a lot. I really like the idea that Rob and Jim talked about calling a lot of these fanglomerates. So you can trace out these old alluvial fan systems within the 6 Mile Creek. And really the kind of difference in grain size is if you want to split this up, I feel like you can divide this into two kind of facies. So you have marginal facies where the sediment is being sourced from adjacent uplifted bedrock within the basin. And then you also have axial facies, or basically facies or depositional systems that are running parallel to the basin and sourcing, basically reflecting the upcatchment lithologies of the basement as opposed to the proximal bedrock. And so to kind of demonstrate how these facies intermix within the basin, we're going to do a little virtual field trip to these stops. And we're going to see a snapshot of what the Ruby Graben depositional system looked like at 10 MA. And the way we know that we're looking at the basin at the same time is we've dated tophaceous intervals at each one of these stops, and they all give about a 10 million year old age. So let's start with stop number 3. So look at that. This is near kind of the center, the axis of the basin. And there we have a fluvially reworked tophaceous sandstone that overlies around the corner these thick, round quartzite cobble channels. If we go to stop 4, which is more near the margin of the basin, we see a slightly thinner but a reworked tophaceous interval overlain by these huge conglomerate deposits, angular As you follow this, a long stripe parallel to the front of the basin, parallel to the front of the range, you can find changes in the class composition of this conglomerate that reflects changes in the composition of the uplifted snowcrest range. So that's kind of neat. And if we go to stop 5, which was kind of near the northern extent of the Ruby Basin where it narrows, near Ruby Reservoir, if you've ever been there, we see an even kind of different looking rock that doesn't, I feel like, neatly fit into descriptions of those Sweetwater Creek, Anderson Ranch, Big Hole River members. And this is the final stop. So walking along strike in a couple 100 meters of outcrop. First, we see a matrix supported conglomerate, kind of a muddy matrix with angular, basically metamorphic class supported in that matrix. Following along the same bed, it then transitions to this, sorry, it's a little blurry, but this very well-rounded quartzite cobble channel that's incised into a tophaceous bed. And then if we follow that alongside, we can even see where another channel incises within the same conglomerate, and that channel is filled with kind of a muddy tophaceous rock. And so I think what we're seeing here at the snapshot at 10 MA is basically at the first stop, we're seeing the axial facies of the drainage, so fluvial systems that are draining the main axis of the basin and reflecting kind of far traveled sources. At stop number 4, we're seeing a deposit that's a marginal facies, so approximately sourced from the uplifted snowcrest range. And then we see some complexities, and this is that complexities of terrestrial systems that Rob and Jim were talking about at stop number 5. So you can see the basin narrows there in orange, and we're going to zoom in on that. And I kind of apologize because this is the area I mapped last year, so this is kind of a screenshot from GIS, not a really super well polished map. But if we zoom in on that mapping, we can see stop 5 is basically a little walk in the 6 Mile Creek along there. And what I think there is we kind of have an overlap and an interfingering between those marginal and axial facies. And what I think the marginal facies in here, that kind of matrix supported with angular class of basement, reflects basically the lithology or geology that was uplifted on the adjacent part of the basin. So these kind of tans and yellows, that's all renova formation, slightly finer grained mudstones overlying metamorphic basement rocks. So I think that lithology would be quite susceptible to forming debris flows. And we kind of have an overlap where you see the marginal facies debris flows coming from the basically margin of the basin, overlapping and being incised by those more rounded fluvial channels of the axial drainage system. So to kind of revisit that first question that I was hoping to kind of touch on. So what's the best way to map the 6 Mile Creek Formation? And I would suggest that I think a facies-based approach is really the only way to understand how basically complex and interfingering these different lithologies tend to be. And so I would suggest, with my initial understanding of the characteristic lithologies of these members, in reality, perhaps a more accurate way to express them and kind of a simplified track column would be something more like this. And I think at 1 to 24K scale, oftentimes we can separate those into kind of 2 buckets. One part of the 6 Mile Creek that represents more marginal facies, so sediment that's sourced from the margin of the basin, and then one that presents more axial facies, so sediment, all right, and I guess depositional systems that reflect axial drainage of the basin. And based on the way that I understood them originally defined in the literature, I think that this is quite similar to the intent of how they describe the Sweetwater member or the Sweetwater facies and the Big Hole River member. So that's kind of how I showed that is there. And importantly is that these overlap the depositional interval, these overlap in time completely, and the interfingering nature of these contacts. But this kind of leaves, what about all the tuffs and tuffaceous beds within the 6 Mile Creek? And so I think perhaps a helpful way to think of those is that those are really beds that are interspersed within the marginal and axial facies of the basin, because you can find these tephra beds and reworked tuffs within, you know, to me, what represents Big Hole River facies as well as Sweetwater Creek facies. And yeah, so they're often thinner in the marginal facies, which makes sense because much of it would have been washed down into the center of the basin. And one thing I really want to emphasize, at least for me, and I got a little bit of validation because I feel like Jesse agreed that it was quite hard, is I think it's almost impossible to tell apart these different tuffaceous intervals just in the field. So with poor exposure, you know, you can have faults that can offset, reworked 10 MA tougher bed from a reworked 8 MA tougher bed, and you really can't tell where you are in the stratigraphy just based on looking at the lithology. So that's why I feel like geochronology of these different tuffaceous intervals is really important to get that kind of age control. And so that's going to lead us into the second main question. And also we're going to talk on a little bit, you might have noticed there's some differences in this upper part of the strat column. And we're going to talk about what led me to think about making those changes. And so that's going to lead us to our second question. What is the timing and possible mechanisms for the unconformities that Debbie Hanneman has shared that bound the 6 Mile Creek Formation? And so we don't have time to really go into the zircon protocol, but much of this talk will be the trial zircon geochronology. So you check out the YouTube video. And yeah, it's quite amazing. For like 10 years, Jesse was carrying the geochron load himself, and just recently, it's a Herculean task. I got to go 3 years ago with Jesse, 2 years ago, Stuart and I went. This last year, Mandy and I went, and sorry, Mandy, you can see it's pitch black out here. It's probably like midnight when I took that photo, but she was smiling, thumbs were up. So yeah, you'll just have to take my word that we can date these detrital minerals. So let's revisit this Timber Hill basalt area. The first place that I ever looked at the 6 Mile Creek Formation with Jesse, first day in the field on the job. And here we can see this kind of northwest trending light green unit here. That is the 6 million year old Timber Hill basalt flow. So in Jesse's little outreach article, a Hawaiian type basalt flow that I think Rob talked about in his talk can be traced all the way back to Lima and correlated, I think, to the Heisey volcanic field. And importantly, Jesse and myself and Jim Sears collected a bunch of samples from these reworked tuffaceous beds in the 6 Mile Creek underneath this kind of resistant topographic high basalt. And interestingly, we got ages that range from 16 to 12 and a half, 10, 9, 8, 7 and a half, 6. So we got a fairly complete record of the expected, age of the 6 Mile Creek and the Yellowstone hotspot track from basically 17 MA to 6 MA. However, we revisit our stop number 3 near the center of the basin. We'll revisit that kind of axial facies, fluvial channels, and we dated that tephra bed to 10 million years old. And if you saw, so we have one of the youngest rocks dated within the basin, and you might have caught this on the first slide, but there's a very small little mesa, again, an erosional high within the center of the basin. That's the Robb Creek tuff that's been dated to 1.9 or 2 million years ago, and is correlated. Jim Sears and some of his students have correlated this tuff to the Huckleberry Ridge tuff of the Yellowstone, modern Yellowstone Volcanic Center. So importantly, here in the center of the basin is essentially we see a 2 million year old rock overlying a 10 million year old interval of the 6 Mile Creek Formation. So basically we see no rocks no 6 Mile Creek Formation between 9 and 2 MA in this area. And so what I think that can help tell us about kind of the timing of these unconformities and the depositional age of the 6 Mile Creek Formation is that we see a complete record from about 16 to 6 MA in the Timber Hill area. And I think part of that is that the resistant nature of the Timber Hill protected those units underneath. But we found no 6 Mile Creek Formation in all our mapping in the Dillon area that overlaid the Timber Hill basalt. So stratigraphically, we could tell was younger than 6 MA, or we didn't date any 6 Mile Creek Formation to younger than 7.5 MA. And importantly, we found that the 2 million-year-old Robb Creek tuff, a Huckleberry tuff equivalent, overlies 10 million-year-old 6 Mile Creek strata. And so I interpret this to suggest that the Ruby Graben basically has been exhuming since about 6 MA, or at the very least not preserving much sedimentation. And interestingly, this coincides with the onset of the Heisey volcanic field. And so that'll lead us to this final question we have. What can the provenance of the 6 Mile Creek Formation in the Ruby Graben tell us about the ancestral continental drainage divide? And so here, this is kind of a cool figure. So I have that same kind of revised facies approach to the 6 Mile Creek schematic diagram shown here. And then in this plot, I basically compiled all of our 6 Mile Creek zircon data from the Bureau and plotted all the grains that were younger than 20 MA. And so this is number of grains in each bin, and we had 23 total samples and 403 grains. And you can see we have a pretty good record of basically tophaceous zircons that overlap with most of the older volcanic centers of the Yellowstone hotspot. So McDermott, Hawaii, Humboldt, Bruno Jarbidge, Twin Falls, and Peekaboo. But we didn't find anything younger than about 7.5 MA. So it seems like when the Heisey volcanic field started to erupt, the Timber Hill basalt flowed down a paleo channel into the Ruby Graben and was a resistant ridge or cap. And so that was preserved, but we didn't accommodate any of those other kind of fluvial 6 Mile Creek sediments at that time. And so if we take this facies approach that I kind of described earlier to the detrital zircon populations, we would expect quite different signatures based on what facies in the basin we're in, right? So if we're in this kind of marginal facies, or the fanglomerate lithologies and stuff that's sourced from proximal uplifted lithologies, or what I call the Sweetwater, right? Jim and others defined as the Sweetwater Creek member. If we look at detrital zircons from that sample, we should see Southwest Montana sources or proximal sources. And if we look at the more axial facies or the Big Hole River facies, we should see, if the models are correct, more central Idaho sources or far traveled sources. And so that's what I did here. So I split up all our samples and I plotted at the bottom. These are just the marginal facies first, and we get a spread. There's a break in the time scale there at 20 MA, but we get a whole bunch of these Neo-Archean and Paleo-Archean ages. These correspond really well with a lot of the basement rocks around Dillon. Get a good Great Falls Teutonic Zone, Big Sky orogeny age. We get some of these 75, 45 MA. There's plenty of local volcanic rocks of that age. And then again, we get some of those Yellowstone hotspot associated ages. And so in the axial Big Hole River facies, those well-rounded, presumably far-traveled sources, we get this age spectrum. So what I did in here is I actually color-coded the green ones are the ones that are also found in the marginal facies, or ones that we don't really need any far-traveled central Idaho source to justify. And that would make sense that some of these, if we have alluvial fans shutting off topographic uplift, that a lot of those sources would make it into the main axial drainage of the basin. But in red, I kind of highlighted some of the ages that we actually did not find in the marginal facies. So differences between the axial and marginal facies. So there's some interesting ages like 1420, 1030, 435, even 95. I think a lot of those could be correlated to rocks that are exposed in central Idaho. And so I'm looking forward to kind of as we wrap up the Dillon mapping and we get these maps and data sets published, seeing if we can kind of provide some further data that would be useful to some of these big picture provenance models, such as the one that Lydia talked about in her talk. So one of the main finding of hers is that most of central Idaho and the Yellowstone hotspot, people believe and the evidence supports drained to the east, which now drains to the west. But one of the big questions is what happens in southwestern Montana. And she's got a few samples from the area that we worked. And I think it's interesting to kind of split it up into kind of this marginal facies and axial facies approach, because there's things we would expect in the axial facies, if this model is correct, to reflect some of these and similar to some of these drainages, up drainage. And we would expect some of the marginal facies populations that we found from the exposed bedrock in the Dillon area to persist or basically enter the system in southwestern Montana. And we could look for those in downstream catchments to kind of test these models of whether southwestern Montana during the early Neogene actually drained into the Paleo-Columbia or was part of the upper Missouri River system. And another thing that was of interest to me is I think Jim Sears and some of the students, Rob Thomas, have already made quite strong and robust correlations between some of these units in the Ruby Graben and the exact Yellowstone volcanic fields. So for example, they can correlate this Timber Hill basalt flow, trace it back to the Heisey volcanic field. They can correlate this Robb Creek tuff at 2MA back to the modern Yellowstone plateau or Yellowstone volcanic field. But I'm curious if any of these, plethora of tophaceous intervals we mapped within the 6 Mile Creek Formation can be strongly tied back to any specific eruption of the older Yellowstone hotspot track. And so this is quite speculative. We don't have, any concrete ideas, but it was one thing that interests me. So I actually found this volcanic outcrop when I was mapping, and it kind of caught my eye. Here's a thin section of it, so you can see a lot of volcanic glass, and I thought some of this looked a little smeared, but I'd really be kind of stoked to look at this with a more volcanic expert. But it really just caught my eye because it looked quite different from a lot of these kind of fluvially reworked tophaceous sediments that we were sampling a lot elsewhere within the Ruby Graben. And so we dated that, and it was 12.2 million years old. All the grains were that age, so very, unimodal age peak. And I just dug out some paper in the literature, kind of characterizing a lot of the eruptions of the Yellowstone hotspot that were around that age. And it overlaps with this specific inimbrite flow here that they call CPTV or CPT5. And this is bulk rock geochemistry, which actually I had a good chat with Jesse. And so this is really the chemistry of the volcanic glass would be a better diagnostic correlation. But it was quite interesting because I just plotted up the geochemistry we had from the sample that I collected and plotted up so overlaps geochronologically and bulk rock geochemistry with this ignimbrite flow from the Twin Falls field. And so I don't know, I think it'd be cool to kind of get someone interested at trying to kind of work out some of those specific correlations. Because if it is true and does hold up, it's 350 kilometers or roughly 220 miles between this eruptive field and where we found it in southwestern Montana. But of course, you'd have to back subtract the 11 or 12 million years of basin and range extension that has separated those a little bit. And importantly for mapping, because that looked like a different kind of volcanic unit that I had seen elsewhere in the 6 Mile Creek Formation, I actually initially thought that it was Renova Formation. It had some quite fine grained smectite weathering or popcorn weathering type features that is common in, I thought I was in the lower Renova, like climbing arrow member. But so that's how I originally mapped it as a fault, dropping 6 Mile Creek onto Renova. And I did feel like there was some, linear expression in the LiDAR, which would be interesting. It's not a big fault, but this had never been mapped before. So that would be another northwest trending structure, something that Rob talked about was common in this area in his talk. And if we trace kind of around the corner, this was my stop five, this SC3 sample that was dated at 10 MA. And so you can kind of trace these beds out in the LiDAR. And if they follow around, it does seem like to me like you'd be stratigraphically above this 10 MA if it was a continuous section, but we're actually in an older rock. So instead of it being, I thought I had another, yeah, so instead of it being a fault that drops 6 Mile Creek onto Renova, it's a smaller fault potentially that just drops slightly younger 6 Mile Creek onto slightly older 6 Mile Creek potentially. And so to revisit and summarize this talk, I kind of want to go back to those three gaps in knowledge or questions that I had. So what is the best way to map the 6 Mile Creek Formation? And really, I'm asking, what do I think is the best way to maximize the understanding of the Neogene basins? And I really think that this facies approach should be considered. And I think one of its strengths is that it's really only a very slight revision to the member-based approach, because I think a lot of these original members were defined by the facies that they represent. And I think this has some strengths. I think it characterizes the geometry of the basin. You can tell whether you're in the center of the basin or near the margin. I think it's useful for things like Whitney's talk, where gravels and grain sizes, because I think it describes outcrop lithology, grain size characteristics without implying a stratigraphic position. But one aspect to this is I really feel like geochronology or fossil assemblages are key for getting sort of any age constraints. I think it's really difficult to tell where you are within the 6 Mile Creek stratigraphy without having those geochron constraints. So what is the timing and potential mechanisms for those unconformities that bound the 6 Mile Creek Formation? Well, the oldest 6 Mile Creek sample we dated was a tophaceous sandstone at 16.1 MA, and the youngest is at 2 MA. So it makes sense that kind of some of the prevailing or original thoughts were that the 6 Mile Creek recorded the entire Yellowstone hotspot trek. But what we actually found was relatively continuous, 16 to 7.5 million year old 6 Mile Creek strata beneath that 6 million year old Timber Hill basalt mesa. But we found that that's 2 million year old rhyolitic tuff actually overlies a 10 million year old, so a stratigraphically deeper level within the 6 Mile Creek, demonstrating that there was incision. So I think that the record kind of shows from 16 to about 6 MA, the Ruby Graben was accommodating sedimentation and preserving 6 Mile Creek stratigraphy, and that would correspond basically to the McDermott, so the oldest Yellowstone eruptive center, all the way through to the Peekaboo Yellowstone volcanic field. However, I think mostly since 6 MA to present, the Ruby Graben has mostly been exhuming sediment. And if you go visit, the little Timber Hill basalt mesa or Rob Creek rhyolite mesa, they're surrounded by landslides. And I don't think they're, wait a couple more million years and there might not be much of them left within the upper Ruby Graben. So I think that kind of coincides with the onset of the Heisey volcanic field at about 6 MA. What can the provenance of the 6 Mile Creek and the Ruby Graben tell us about ancestral continental drainage divide? I think there's definitely a difference in provenance based on facies, which makes sense. And one thing that I think is important is I feel like overall just the complexity of this terrestrial depositional system is we're not getting a well-mixed detrital zircon population. So I would say intersample variation is very high. So I'm not sure that I would feel like, one sample could characterize the entire formation. And I think most of the trial zircon ages that we found can be correlated to local basement, local igneous rocks, or recycled from nearby exposed strata. And so I think kind of those unique populations or the differences between kind of the marginal and axial facies may be key because they may represent the zircons that were not proximally sourced and could reflect the you know, big picture drainage divide story. And I thought it was kind of funny because I love this quote. And I actually asked Chat GPT to show a geologist depiction of the you don't need to reinvent the wheel, just try to improve it. And I feel like as a mapper here, I feel like that's kind of our goal. There's always great framework, and we go out there, we get awesome opportunity to look at a bunch of the rocks. And we don't need to reinvent the wheel, but hopefully we can at least improve it. I thought it was kind of funny because I was like, oh, maybe this is like a Susan or Debbie or whatever, and then it depicts the geologist me as a caveman. So maybe that's kind of fitting. And yeah, I'll take any questions. I've had happiest years of my adult life living here the last 3 years. So yeah, thank you all for coming. And yeah, any questions? Happy to take them.
That disconformity between the 10 and the 2 million-year-old rocks, what is it doing in the center of the basin, whereas like the section beneath the Timber Hill is like pretty continuous, but that's like in the footwall of the fault?
Yeah, I had good question. I might show because I'm actually I was trying to find, I think it's actually Jim Sears paper, but it's behind a paywall and I haven't gotten it. Talks about the tilting of these basins because it is kind of interesting that like these basins have tilted. So you can even find like the axial, you can trace out the large river systems that were draining the axis of the basin at like 10 MA, and they don't align with the modern drainage of the basin. So it has been tilted. And I think, for example, like the Upper Ruby Canyon here, that probably I suspect it's quite young, like maybe even quaternary, and that eventually, when this Upper Ruby Graben was filled, the 6 Mile Creek Formation actually kind of spilled over that area there. So I don't know if that really answers your question, but I am kind of interested in the tilting of the basin that's happened because overall, uh, most of these tertiary sediments are gradually tilted into the Snowcrest Greenhorns Range Brown Fault. So most of them are slightly tilted east, is my interpretation, or northeast, I guess, a little bit.
The questions in the chat looks like. Yeah.
6 Mile is tilted down to the southwest. I guess
Maybe
I'm not quite sure what that comment was.
Maybe he's talking right up to
Rob?
Hey, Dan.
Yeah, hey Rob.
I was just trying to answer the question on tilt. The Renova is steeply tilted to the southeast towards the snow crest, and it's eroded off. So you have it on one side of Timber Hill, you have it on the southeast side of Timber Hill, but you do not have it on the northwest side of Timber Hill. So when you draw a cross section across the middle mesa, the Renova is going across that southeast to northwest cross section. And then that was, Jim and I have got that in papers. And then it's the whole 6 miles tilted down to the southwest into these northwest trending normal faults. Not steeply.
Yeah, right there.
Did you catch that, Dan?
Yep. Yeah, I mean, yeah, I found it really difficult to trace really any of these northwest trending faults to any like significant extent out here in the basin. I do think a lot of like in the more towards the center of the basin, that overall most of the 6 Mile Creek overall tilts mostly into that fault fault.
Back question.
Yeah, yeah.
So I like the feature approach is great. But I guess the problem is like, the truly marginal sediment species are easy to detect. They're kind of coarse grain, oval fans, and the actuals are with more and more channel. But the tough part is the interfingering too. Because you can't really tell between a distal fan and a British channel.
Yeah.
Species, they could be doing that. Right. And so how do you kind of resolve that? You need to do a sequence security. Did not figure that out.
Yeah, I think it's one of these by definition a broad gradational contact, especially when you're looking at the outcrop, you're looking at a specific outcrop, you're looking through time, and the base of it might look like one, and then it, as you move up section, it might look slightly different. So I would totally agree that they're very gradational, kind of overlapping contacts. And one of the ways that I kind of got around that is, you can't even really see it right here, but I actually mapped this this darker orange as tertiary 6 Mile Creek undifferentiated, and then this kind of lighter pink orange as more of the marginal facies. So it's a little bit of a cop out, but kind of these axial facies, by the way I grouped it, could contain some some of these more marginal source deposits, but overall, predominantly, I thought they reflected more axial drainage facies, whereas like where I traced it out here, they looked like predominantly all the source was coming from kind of transverse or from the edge of the margin of the basin. So that might be one way kind of around it.
Another way would be to do patio direction. Stuff.
Yeah, I would. I attempted to kind of measure some like cobble ember kits and stuff like that, but I thought it was not really my directive, so I didn't measure too many of them necessarily.
A lot of the little basins, like in the Dillon area, I think are like small enough that it's not really an issue. It's like near Block Mountain, it's like the fans come into the fluvial channel and they're still pretty close to the source, so you can tell them apart pretty easy. So I think that's probably only a problem in like the bigger basins. So in like a lot of the northern Ruby that Dan was mapping, it probably isn't much of an issue.
What is the fan for conglomerate even the right model? As opposed to just the large braided channels.
Yeah, I could definitely learn more about the specific depositional characteristics to definitely identify them. So I don't know if I would say I'm 100% confident in the alluvial fan model versus some other alluvial characteristic, but there's definitely a difference in class composition and sorting, angularity, size.
Dan?
Between the two. Yeah, Rob?
So I had a student, Sherry Landon. She did a three-dimensional paleo reconstruction of the Ruby Graben. She measured 35 sections and did cobble imbrications. And so we got a temporal spatial reconstruction of the Ruby Graben from the bottom to the top. And those fans they all have, you have it right. They're being derived off of the basin margins towards the axial drainage. The paleo flows are very tight in those alluvial fan deposits. The cobbles are, angular basement and tertiary volcanics. Very little in the way of, big hole gravel, the well-rounded belt cobble stuff. And then they interleaf with the belt cobble stuff as you go axial. And then all of her paleo flows show the axial flows to be 180 degrees to the north east. So it was flowing from the southwest to the northeast the whole time. It never reversed. and the paleo flow has about 180-degree spread in it. Probably these are meander or braided channels for the most part. So the alluvial fans are definitely coming down into the axial drainage and then interleafing with them. And then the tephras, as you said, they come in, when there are eruptions. And I think they come in as, in part, are coming in as debris flow. They're lahars. I think some of them are lahars. You probably looked at the East Fork Blacktail section, and you can actually, you can really see their lahars there. Um, there's weird sedimentary structures that show uh, the kind of debris flow deposition of ash that kind of defies sediment transport calculations, and itself is a whole, worth a whole dissertation worth of work, uh, looking at what debris flow deposition in grains that are light, and different than siliciclastic sediments looks like. Um, so anyway, that Sherry has the three-dimensional uh, stuff done. Now ended up in an abstract, and unfortunately, she's an undergrad. It never ended up in a publication, but I have all the data
Yeah,
and happy to give it to you.
yeah, I would love to go. Because that's the kind of Anderson Ranch type section in the Blacktail, right?
All three members were originally defined by Bill Fritz and Jim Sears at Timber Hill.
Hmm.
Um, and it, so, the question that I've been bringing up in all this ad nauseum, and I apologize for it, is, what is 6 Mile outside of the Ruby and the Beaverhead Grabens? Because they become very different things. They just become post Renova deposits in a lot of the rest of the world and in Montana, but yet they're still called 6 Mile Creek. And Jim gave a talk at GSA, for example. I'm not talking out of turn here, but he had mapped stuff that was 6 Mile Creek that was sitting on the Renova, and it was a cap. It was a cap of coarse grain material that formed a flat top, but it actually descends in elevation going down the hill. It's a pediment, and this was over in Missoula. So it's called 6 Mile. It's mapped as 6 Mile. We have a problem. We're mapping everything that's post Renova as 6 Mile, and it's because we take a chronostratigraphic approach. And these deposits in the Beaverhead and Ruby Graben are fundamentally different than all the rest of the 6 Mile because contain these three, members, which you're right, are interbedded facies from bottom to top. And they do not they don't correlate. If you're looking at 6 Mile equivalent in Drummond, or you're looking at 6 Mile equivalent in Missoula, or you're looking at it anywhere else, it's not the same thing. This has to be addressed.
Rob, I would argue that the sort of big hole basis, can you hear me, Rob? It's calling.
I can. I know it's you, Colleen, right? I knew it was going to be you.
You should have seen her face.
All right. Go, go ahead
You wanna
and
come up here,
take
Cal?
me down. I'm ready.
No, but I would just say that the fluvial facies style of 6 Mile or post Bernova and the no, I've already lost the name, but the marginal facies
Sweetwater.
facies, the Sweetwater style facies, those ones you can map pretty widely. And I will grant you that we do not have a lot of geochron data for those post-vernova gravels, but we do have some. And they're consistently Miocene. And the only thing that's really missing are the tephra, the Anderson Ranch.
Right, but
And that is specific to that rock.
all right, I'm pushing back, Colleen.
Which part?
So we know from having reconstructed, done voluminous paleoflow measurements in both the Beaverhead and Ruby Grabens that those are basin margin deposits that have paleoflows going into the axial drainage, where they then are intermixing with gravels and tephras, which are the axial drainage deposits. We found only one airfall ash in 30 years of work on an alluvial fan, so therefore probably an airfall ash over in the Beaverhead Graben up Stone Creek. That's it. Everything else I saw was fluvially reworked or was primarily deposited as a lahar in terms of the tephras. The gravels, I think, are largely reworked out of the 6 mile. That's a point of contention, out of the Beaverhead, which is a point of contention between Jim and I on this, because the initial work was trying to tie these two gun barrels, the Ruby Graben and the Beaverhead Graben, back to the hotspot, and Jim had exotic class, right, like the Milligan shirt and so on, and the big hole member. But you don't need to go to Idaho to derive them from primary sources. They can be reworked out of the Beaverhead. And I had a student do a decay curve on those gravels, and they decay curve out of the Beaverhead conglomerate much better than they do out of off of primary outcrops in Idaho. But it hardly matters because the tephra you can trace practically all the way back. You can trace the Timber Hill basalt all the way back. The drainage divide that we see today wasn't there 4.5 to 6 million years ago. I think it goes a little later than six, Dan, because Timber Hill is overlain by quite a slug of gravel if you just walk it back towards the Blacktail from Timber Hill, because it's tilted down to the southwest, and then there's a crap ton of gravel sitting on top of the Timber Hill basalt flow. You can particularly see it because it's faulted, a zillion times, right, by northwest trending faults. And in those down tilted blocks, you can see big wedges of big hole river gravel deposits. I hate that bloody name. In those down tilted blocks. So we don't have good age control on it. But I agree with you that, the Timber Hill basalt flow preserved that. I think it extended across the basin, and it's been dissected, and the question is, when did that dissection start? But it doesn't really matter. The point I'm trying to make is that uh, these drainages tie directly to the calderas through that period of time of 16 and a half million years. And let's just split it in half and call it 5 million years. And so this idea, I saw, that paper that has the red rock as a drainage into the salmon. I don't see any evidence for that at all. Do you?
That was for Colleen, right?
Yeah, that's all based on that big leap of faith. Ruby Graben off the railroad camp or Drummond, right?
Yeah, and so that's kind of this
That's
thing with Lydia
it's Lydia's stuff. And
That is wonderful.
this idea that it's going down the Red Rock Valley and crossing the Big Hole and going into the salmon, there's no evidence for that.
There's pretty good evidence against that.
Could
Yeah.
with the capping gravel on the Timber Hill, could that be a pediment of reworked 6 mile, like you were talking about with the example that Jim was showing?
Yeah, there's both, Stuart. And the reason why we know that is that Sherry measured the cobble imbrications in those. And so the pediment gravels come from the east, southeast, coming off the snow crest, and the big hole gravel member are all imbricated uh, to the northeast. So you can actually see that you can define the boundary between the 6 mile and then the reworked pediment on top of the 6 mile. I can do that in a half a dozen places.
Yeah,
Um,
yeah. Because of different things. Yeah.
I'm not sure that we disagree, Rob. I think we need to sit down over a beer.
Yeah, no, I'm with you. I'm just gonna, I've been fighting this fight for a long time. That the 6 mile and the Beaverhead and Ruby Grobens, as Dan very nicely points out, is just fundamentally different than 6 mile elsewhere. And I think, as Dan really pointed out well, once again, um, I think whatever helps us to best understand Neogene of of West, wherever we have Neogene in Montana for the Bureau and others, that's how it should be mapped. And I agree with that. I just know that the deposits in the Beaverhead and the Ruby Grobens are really kind of fundamentally different when you really scrutinize them and look at the details of the paleoflows. I mean, not only do you have this uh, facies change laterally, Dan, but there's a temporal change. So when the Grobens started, the axial drainage was small, and over time, the axial drainage got larger and covers a bigger part of the Graben, and the cobbles get larger. And this is the gradient of the whole, the hotspots getting closer, and the gradient gets steeper and steeper and steeper, and it's able to move beaverhead conglomerate materials, they're prograding to the northeast as the gradient tilts higher and higher and higher. And so by the time you get to the quote big hole gravel member, you're now you're losing Sweetwater Creek member. You're getting mostly big hole gravel member, and the cobbles have gotten huge because the gradient is greater, and you've got greater bound of shear stress to be able to move a larger cobble because of that increased gradient. And so, Colleen, to me, this is so well defined now, these two Grobens and this three-dimensional temporal and spatial understanding is so good that I know that it's like tremendously different than it is, say, over in Drummond or over in Missoula. And to call those 6 mile and have them be the same as what is down in the Dillon area, in my opinion, is really just wrong. They're not the same. And what's happening is people are making mistakes and calling things like pediment gravels uh 6 mile.
I think feel free to go if you have to go.
Sorry, I didn't mean to
No,
go.
no, I feel this is great conversation. Admittedly, I have not looked at 6 Mile Creek stuff much outside the area that I was responsible
But
for.
Colleen's done a ton, and she's, right on the money in that, there are these kind of angular classed Sweetwater, like looking things that we call, 6 mile hither, thither, and yon that, lack the tephras. Um, but I guess what I'm trying to point out is that when you look at those two Grobens, the Beaverhead and the Ruby Grobens, temporally and spatially, they are so, tight. There's a story there, that a temporal spatial relationship to two northeast trending grabens that were active from 16 and a half to, I would argue 4.5 million years, that they deserve, you know, I don't know, something different than what you would call 6 mile hither, thither, and yon elsewhere. Is that, Colleen, what do you think?
I think we need to drink over this one, Rob.
Okay.
Yeah, I think the problem is that, I mean, our approach has been going basin by basin, dating everything we can, mapping facies. And at the end of the day, we have to put a name on it, so we
Yep.
use
Yeah.
6 mile as a name, but only when we
Or-
have to, or just tertiary sediments.
Or
Uh,
mile equivalent.
Yeah,
And then if you go back to the type section of the 6 mile, that's not the same as the Ruby and Beaverhead.
No,
And
I
it's.
know it. I know it's a problem.
Yeah,
And
it's-
and you can't even go on lithology because of course, the Renova over in Suzanne Janicki land, is, you've got syntectonic conglomerates, it's coarse, right? Outside of the lake, the Medicine Lodge beds and other lake sediments, the Renova can be like super coarse to the west and be very hard for people to determine, to distinguish that from 6 mile, especially if you can't see, an angular unconformity between the two, which is there. It just hard to see. Um,
yeah.
and
And my point is that as we like work across the state and we get like bigger maps, if we want to not have 200 individual lithostratigraphic units,
yeah,
then it ends up becoming a chronostratigraphic unit where it's just basically tertiary sediments or Miocene sediments or something like that.
yeah,
So I mean, practically it just ends up becoming a chronostratigraphy, and you said it yourself, you can't, really make the lithologic leap from basin to basin. So I don't know of any other way to do it other than just treating it as different chronostratigraphic age equivalent basins. And then
which is
yeah.
Yeah, that's exactly what's been happening. And you're right. You and I had this conversation before, and I think, from your all perspective at the Bureau, that may be the best thing to do, right? Is just to treat it that way. And then hope that what happens in the mapping is that people can, make certain that they're not, erroneously mapping pediment surfaces or even younger like debris flow deposits. For example, there's young debris flow deposits mapped over Stuart, because you just mapped it at Block Mountain that they I don't think they're 6 mile from what we were just talking about is 6 mile and Dan stock.
Yeah,
You know what I mean?
sure.
Yeah, but they've always been called 6 mile.
Yeah.
And and they've been mapped as such, and they're not 6 mile. They're something younger.
But if you were to consider it as a time transfer city, then you'll have to say.
But then how do you define it if it doesn't have, like Dan says, if it has these facies changes within basins and it doesn't have a time pin to it?
I know.
How do you, it just becomes a lithology map, not you lose any stratigraphic information,
Yeah, I don't have an answer. This is why we're still discussing it 30 years later,
Yeah.
or more. My God, because Jim and Bill, have been at this, since God was a child, and Jim had it all worked out the first day he walked out onto the field. He just drugged the rest of us, kicking and screaming along, to understand what he knew, right from the get-go. But you all understand, the genius of Jim Sears, and he deserves the credit. in many ways, for this. But yeah, I don't know. I didn't mean to get off on this. I apologize, but
So
Dan can see it now because he's been through it. And they're very, very specific. There's a very specific deposit type in the Beaverhead and Ruby Grabens, which were absolutely separated from one another because the paleoflow measurements in the alluvial fan deposits show that they flow to the southeast into the Ruby Graben off of that, I'll call it the ancestral Ruby Mountain High, and they flow to the northwest into the Graben. And so there's a topo high that is roughly correlates to the modern northeast trend of the Ruby Range. And you can absolutely see it in the paleoflows in the alluvial fans. And then the two axial drainages, they paralleled one another in the Beaverhead and the Ruby Grabens. And where they met up, I don't know. I think they met up on the other side of the tobacco roots.
Yeah, I was gonna kind of think about that for Lydia's model of like how does this
Yeah.
the Ruby Graben drainage then cut back over into there's not really anywhere to put it.
I mean, I'm just going to be blunt, and that's wrong. I see absolutely no evidence for that. You agree with that, Colleen?
Yeah, no, I can't see any way of doing that.
No, there's just no evidence for that.
uh, I think an important detail though is that in Dan's stuff, that he pointed out the DZs, where you need to go further south, and Jim has his cobbles and that he takes from the south. And you pointed out you know, possibility of reworking from Beaverhead, which I agree with.
Yeah, there's no question.
So anyway, I think in terms of like the provenance ties she's making and the similarities she's making, there's a lot of truth to it, but the timing could be anything from Beaverhead on and reworking several times, so
All right.
so I feel like ultimately like the provenance studies are pointing in the right direction. To me, like this big pile of quartzites in like the around the eastern Snake River Plain, like in the Tetons and stuff, and in the Ruby Graben and the Beaverhead and blah blah blah. And so anyway, I don't think the timing is. I think the timing is getting conflated in some cases, but I do think that the provenance is generally pointing us in the right direction. So that's at least useful.
Yeah, I mean, there's a section in Chute Canyon in the Red Rock, in the Tendoys, and so Sherry measured that section in there, did cobble class, did class counts, did provenance work on the cobble types and the imbrication, paleo flows, all of it. Um, and there's tephras in there. Shane and Shane, did you find that work, Dan? Those are the
That does not ring a bell.
Okay, so there were two folks from Toronto that came in and did the chronology on all the tephras. Um, what, again, 25 years ago? It was in the 90s. And Jim and I, ran them all over the place. They collected samples and then they did the chronology on the tephras. And so there is a chronostratigraphic framework for the Beaverhead and the Ruby Grabens from the tephras. But unfortunately, that also only ended up in an abstract, not in a paper. Um, Jim probably has some of the uh, raw data, or could get it. But that's where we used to base it on, were those. And but those were quick grab samples. I would love to see sampling done to do the chronology on the 6 Mile and the Beaverhead and the Ruby Grabens, stratigraphically driven right? So go out with, there using this three-dimensional framework we've got for those two Grabens, sample and put together the chronologies again for all that. I think that needs to be done. Although you've done it, that's great. At least the start of it. You've got a patch of it in the Ruby, but there's a whole section of the Beaverhead to do too, and we need to go north and we need to go south, and in both of those Grabens and get all that stuff worked out chronologically. Um, but in any case, like, my point with the stream drainage into the salmon is that you can see northeast trending paleo flow into the Ruby Graben uh, at Chute Canyon in the Tendoys that has to go at least to the age of Timber Hill, and I would argue slightly younger than Timber Hill. So that's going at least until, say, 4.5 MA. It was flowing northeast. And then the northwest trending horse and Graben started to develop as the plate it collapsed, right? The plate moved the hot spot to the northeast, and the uplifted terrain around it collapsed and formed those northwest trending basins and ranges. And Anders at Lamont Doherty did a study on modeling that and showed that's exactly what would happen in the models. So paleo flow into the salmon, I don't see it. I see no evidence of when that would have happened.
Nobody here disagrees with that.
Yeah, I found it really disturbing. So,
Well, but I think her story from the Washington perspective is really solid. So I think looking at other places like Railroad Canyon or Lost Trail
mm,
Pass, she doesn't know the area as well as we do. So
yeah,
she was just going where the most information is.
yeah,
But I think she's onto something, and it's
yep.
really, I think we should follow her lead. It's not there, but it might be somewhere nearby.
Yeah, you know where it could be, Stuart? There's a big slug of gravel with a paleo flow to the northwest in the Lemhi Valley.
Yeah, exactly. That's what I was. Yeah, and whether that goes through Railroad Canyon or over Lost Trail
Yeah,
Pass,
yeah, yeah,
up the Beaver Big
yep,
Hole. If Colleen wasn't sitting right next to me, I might say that, but
yeah.
you know,
You say that it's flowing northwest in the land?
No. So there
Yeah.
was a pile of gravel in the Lemhi Valley that I went over and looked at years ago as possible big hole gravel member, within the Beaverhead Graben. And it's not, yeah, it's not the same lithologically, and the paleo flows are not to the northeast, they're
No.
to the northwest. And so I excluded that patch of gravel as being part of the continuation over the Continental Divide of the Beaverhead Graben, the Neogene Beaverhead Graben. But I never felt like these gravels were needed to prove the case that the current Continental Divide wasn't there until 4.5, 5 million years ago, because the tephras show that. Because the tephras are not airfall, they're fluvially and lahar deposited down a drainage that came off, in my view, came off of the calderas, and so they're the tie to the calderas. You don't need to have the gravels are not relevant, is my point.
it sounds like we should look at the Lemhi and Bitterroot and look at that connection, see if there's a connection anywhere in there.
I think so. I think that's the best chance. Absolutely.
Biggest problem is that the exposures are terrible.
They are. I know.
There's no actual outcrop. You just see a bunch of
I know.
a bunch of cobbles lying on the ground and
Yeah. There is a hill Colleen of gravel. I'd have to look at a map again. It's been so long, I can't remember what the damn thing is called, but
Begins with
it's
gravel pits.
it's a hill of
Video.
gravel, and it's south of the turnoff to Gilmore. Uh, I just don't remember what it's called. It's probably got a name, but there's a hill in the middle of the valley, and it's a big slug of gravel. But the paleoflows are to the northwest. They're not to the northeast.
I feel like this is the preservation bias problem that Debbie Hammond.
So if I
brought up.
stop recording now?
Yeah, that's cool. Go for it.
Yeah, sorry guys.
No, this is